Welcome to another episode of the Agronomy Highlights podcast. I'm your host, Ryan Spellman, and I'm joined here with my co-host and colleague, my lovely co-host and colleague, Justin Brackenridge. How are you doing today?
I'm great, Ryan. How about yourself?
Justin, I'm living the dream.
Good. I'd be
Yep.
sad if you weren't.
I know. One day I'm gonna say otherwise, and,
Oh,
and we'll
please
just have to
don't.
end the podcast there. Um,
Yeah, no. This has got to be an extra special day for you, right? 2 weeks ago we did um, funguses and fusarium, and we learned about spraying our wheat, and now we're getting into some other cool topics that you're really passionate about. So this you ought to really be excited.
that's right. We're on a roll here. I think I've let you bring on enough forage guests,
Yeah,
so
I've been hogging. So yeah,
It's
it makes
it's
sense.
about time that I let our audience into my world of plant pathology and biologicals and you're right. I did spend in my pathological pursuits. I spent a lot of my energy thinking about biologicals, and I think over time I've kind of gone between hopeful optimism in how they can be used in our agricultural systems to a little bit of, I guess, reservations on how they're actually implemented. And I think there's a lot of opportunity and maybe a lot of traps in this world that we're seeing currently. And so I think it will be great to have someone on today who can speak to some of the different products that are out there, some of the things that are there that are going on in the biological world and still need some work, and can kind of help us navigate the plethora of products and mode of action of these products around us. So I don't know, Justin, do you see a lot of farmers in your area that are interested in biologicals, doing work with them? Where do you see this in your area of Western Pennsylvania?
So as a natural born skeptic, right? I kind of have to bring the wet blanket to this conversation. And I think we're always challenged when we're putting or trying to understand living things in a living environment and a living system, right? I think there are so many different ways that they can react all the time. And I really appreciate the people that do the research on this. And Ryan, you and I were talking before this started. I see a lot of people that are really interested in this, and I think there's a ton of maybe misunderstanding or confusion of I'm putting a biological, I'm putting a micronutrient pack, I'm using it at this point, it's foliar, it's on the seed. There's so many different directions this can go, but what are people actually doing to kind of fact checking? Does it work? Right there, was it just a great environmental? Fertility was really good. Did this actually have the impact you thought it did? Or did you want to see the impact because you paid $6 an acre to put it out there, and by golly, if I'm going to do it, it's going to work. And so there's so much of this that I always push for us are bringing back this old term citizen scientists, right? I'm always pushing the guys and the folks that I work with that if you're going to do this, put in a check strip or call me to do like a way wagon or something, right? Like let's not everything has to be replicated 6 times and put in a journal. We can learn something, and so I'm really excited to have someone coming out here to talk to us today that does do the check strips and writes the articles in the journal that can validate some of this stuff and help us sift through what's real and what isn't. So looking forward to learning. I like to learn on these as much as I like to just sit and talk. So let's get to it.
Yeah, definitely. Let's get to it. I think that's right. It's there's a lot out there, and the check strips are important. Hopefully, we can talk a little bit about that. So, Dr. Connor Sible of the University of Illinois is here with us today. He spends a lot of his time doing work with biologicals as well as looking at plant microbe interactions and how that kind of is influenced by agronomic practices. So before I go too far and butcher what he really does, we'll let him introduce himself. So, Dr. Sibyl, thanks for joining us today.
Thanks so much for having me. And it is an exciting topic, something I've been working on for quite a while now. When I started grad school back in 2017, it was on this topic. I think it was at that time just getting started. So it was perfect for a graduate thesis project. Then really got into it, and the industry kind of picked up, and there's a lot there. And so been working on that now since 2017. So going on my ninth year, ninth season coming up this year. So really excited about that. I'm a research assistant professor at University of Illinois, where I happen to also do my grad work and my postdoc. So I kind of like to say I'm a true Illini inbred. But with that, I had a lot of momentum too. And I think that has really helped get a better understanding of this space because went from one position into the next on the same topic at the same place. And we got a lot of momentum and learned quite a bit in a short amount of time relative. So, yeah, excited for the conversation.
Yeah, sure. So could you tell us a little bit more about maybe what your research focus is currently? You know, some of the things that see you, that our audience can't see you, but you're actually in your truck right now out in the field. So clearly you're doing a lot of work out there. And what are some of your main focuses at this point in your career?
Yeah, coming to you from East Central Illinois, which is a little bit different from your region, what you're familiar with. So out here, it's pretty well corn or soybean, a little bit of wheat down in south, and then some specialty crops. You know, we are number one in pumpkin and horseradish. So there's your fun fact of Illinois. But that's pretty much one county that comes out of. So the major focus of my research is agronomic management for corn and soybean production systems. What that very vaguely means is we kind of look at everything products and practices that a farmer can do in the field to try and largely for us it's a yield bump. I mean, we're looking at yield as our primary metric of interest on that, largely focused on nutrient use and fertilizers. And what started this whole biological space is a lot of the marketing puts them in that nutrient management category. So by default, we started working on that as well. But products and practices for corn and soybean production, that's the main focus.
Sure, and I think that that element there that you said, most of your research is focusing on kind of the field applications and looking how at how your agronomic practices increase yield, and I'm sure in that increase your product profitability. That's a really crucial part of the picture when we're talking about biologicals, right? A lot of the stuff that I often see, it's not always proven and practiced out in the field. And oftentimes, you know, it might be in a lab setting that we see some of these results, and it's a whole black box of how these interact with our field. And that's not to say they're not effective and great. We oftentimes don't know exactly that, and that's why we need people like you to help us understand that a little better. So why don't we start there? Why don't we talk about biologicals? What's your definition of a biological product?
That's a great question, and one that is in the eye of the beholder. How you define these products does determine how maybe who you're talking to. There's different levels, so like my viewpoint would be the extension kind of type of definition, but there is then regulatory for those that follow this market. The U.S. hasn't quite figured out exactly where they want to land on a legal definition that can then help set up the regulatory process for things that ultimately produce a label. To give an example, FIFRA is where all of our pesticides go through. I mean, there is legal laws and documentation and language to what defines a herbicide, a fungicide, and insecticide, and all the requirements needed to submit to get those approved for use in the field. The biologicals, or often also referred to as biostimulant space, it's kind of like the Wild West, is what we say, because the government doesn't quite have a defined, agreed upon definition. But if you do look at the literature and what's being done in the European Union and other countries across the globe, the general definition is substances or microorganisms that are going to help benefit nutrient use efficiency, nutrient uptake, or mitigate tolerance to stress, and thereby improve the quality or yield of the different commodity that you are looking at. How these maybe differ from other inputs, you'll notice I did not say direct improvement on plant growth. That would be PGRs, which are regulated. And they're not a direct nutrient addition because that would be a fertilizer. So they're improving the nutrient use by the plants, mitigating their stress, and then ultimately getting you a crop quality or yield. But that's the big, broad description or definition with the biological slash biostimulant market today.
So let me, wow, that was a lot, right? So if we kind of break this up, and in Pennsylvania, we do a lot of work with pesticide education. So I'm hoping that every person that's listening to this that goes to our pesticide meeting knows what FIFRA was when he said it. But that's the Federal Insecticide, Fungicide, and Rodenticide Act. And so that's the big bunch of papers that regulate these things, right? And so that's basically you're saying they're looking for a home for biologicals within that department. The other thing you mentioned were growth regulators, right? The PGRs. Those have been around for a very, very long time. And they are already well established as their own thing. And what governs and controls those?
Those are also through FIFRA, just
Okay.
like the herbicides are. Yeah, exactly. And the key thing that there is if it's a direct effect on plant growth, bigger roots, bigger shoots, directly, PGR.
So
I need lots of clarification. Sorry. So I'll ask the dumb questions and then Ryan edits me back out. That's the relationship we have.
No such thing as a dumb question.
Stick around. We got 45
we'll
more minutes.
and we'll find out here on Agronomy Highlights podcast.
That's right. Yeah.
So what you're saying here, and sorry if we harp on this a little bit, is a biological product. We're looking at indirect effects then for it to be defined as a biological product. So traditionally, maybe what I always thought of is like you have biologicals and then a microbe that produces something, and that becomes a biological product. But that's not really the case because you can have other maybe non-chemically engineered substances that are produced by a microbe that have a direct effect, and that would make it not a biological pesticide, right?
But
Or
see,
sorry,
and does
biological.
that come from our like years of agronomy and thinking about this in terms of like inoculation, right? Like I guess that's where I'm thinking is soybeans or clover or something like that that's inoculated. We put a biological on it, therefore it fixes nitrogen, and now we kind of have this direct relationship. But you're kind of blowing this thing wide open with what you're saying is a possibility here through biologicals by definition.
Exactly, and it also goes back to in the definition accepted by the EU and what likely is what I'm seeing with all the discussions going on in Washington. What we're going to follow suit here in the U.S. is that term biostimulants is technically the proper term, and then under biostimulants we get into all the different types of products that could go there. Just like if I say fertilizers, right? I could be talking nitrogen or phosphorus or potassium or sulfur, so the subclasses. And the biostimulants are largely split into two groups, either the substances, and as you alluded to, Ryan, the types of products a microbe might produce, or beneficial microbes themselves. And you almost have to split the conversation in half then. Are we talking about something that is alive or something that was produced by something that was alive or was alive and then we terminated it and you get all the goodies? And it does complicate the discussion. I think that's why there is so much care being put to how should we define or regulate these, because there is a lot of different flex and options within that category. And we could definitely argue they're distinct from the PGRs, they're distinct from pesticides and fertilizers, but within them, how rigorous do we get? I think is a lot of where the discussions are going. But to bring it kind of back, we're either talking about the living or the dead is the way to really oversimplify it. It's a live microbe or something that was alive or produced by something alive. And I'm really glad that you mentioned inoculants that we're so familiar with in these, legume-based systems. People often forget when they say, "Why are we talking about biologicals so much in the last decade?" And I'm like, those legume inoculants that have been around are like the original inoculant or biologicals, and they're never put into this discussion. It's all the new stuff that gets the buzz today. But those legume inoculants, that's basically the original biological. So I'm glad you mentioned that because I
Given
think it
enough
often
time,
gets
I can
left
make
out.
anything about forages. You gotta open the door just a little bit, and I'm like a mouse. As soon as I get my head in, then the forages just follow. So with all of this big area and all of these different, I'm gonna probably take this oversimplification of living and non-living. Where do we really see these most fitting into the agronomics? And where, I guess specifically, let's talk about your work and where you see that kind of future fitting in agronomy.
That's a great question. And what I like to start with, because marketing is sometimes a little bit different perspective than what we're likely to see in the field. And what a lot of the marketing of the biological biostimulant space would suggest, this is an ability to reduce your nutrient inputs because you're going to make up for that with the product. But one of the things that, going back to when I, kind of talked about what do I do, yield. I really love yield. and I don't like necessarily do things that might take yield away, unless we can really say profitability goes through the roof. But when we start removing inputs, then I look at that as you're potentially removing yield potential. And I'd rather maintain the yield potential and then maximize the realized yield at the end of the year with some sort of product practice combination. And that's really where I think the rubber meets the road on how we do these. I'll give you an example. There's no biological today that will fix your pH. I mean, if you have a pH problem, you have a pH problem. We need to be looking at the amendments to fix that first. Then we can start looking at these other products top of that. Your hybrid or variety selection is huge. I mean, nobody puts the same genetic on the entire farm. We know we specify certain genetics for certain fields. And if we haven't quite gotten that up to scope, we're probably not ready for then trying to maximize its yield because it's already been put in a situation. And then the last thing, back to the pest conversation, you know, anything that takes away yield is going to just counter something else we try to do to get you more yield. So we don't have our pest management under control. Anything else we throw money at is probably not going to have an advantage. So back to your original question, as I keep rambling here, if we're going to start looking at these specialty products, don't forget the basics and go back to them. Or another thing I often hear is, well, we've been doing the same fertility, pest management, and hybrid selections the last 10 years. I'm really happy with it. Like, have you tried to change that in the 10 years? And maybe your basics are a little bit out of date before we go to the next step. But definitely what our research is showing is these specialty products are a what's next once you have the basics covered.
I like the way you set that framework as these being a specialty product and maybe not something at the current time is a replacement for something else, right? So it sounds like what you're saying here is that the biologicals fit, and you use the word, you're maximizing your realized yields from the, in that space between what am I actually realizing of my yield potential. This can be what pushes you closer to that yield potential, right? And I think me and Justin have had these conversations before of some of these ideas of the that you hear going around of what's the potential yield of corn, right? It's a theoretical. I think, what is it? It's 1,300 bushels or something like that, right? And so this is kind of that's an exaggerated point that no one even knows if that really exists. But that's where these biologicals exist. Once you get the basics right, you have your fertility nailed down, you have a crop rotation that supports good soil health, and you have a functioning environment. Then you can add these as a value-added product to really push the system and see how far you can reach. Is that kind of how you're seeing it?
Exactly. And to put perspective, that's with today's products. I am excited about this. Where it's going, I think, has huge potential because the biology, when we think about especially on the living microbe side, these microbes are cool and we know they can do it in the lab, but how do we translate to that field and get that to be consistent? So today's recommendation would be the way you phrased it, helping us achieve more of that realized yield, not necessarily try to replace another input. 10 years from now, if we were to redo this, might be a totally different conversation, especially in today's day and age. Technology moves so fast. I mean, it's almost hard to keep up, but it does get you excited about where this whole market could go, and maybe we will get to that replacement. But also keeping in mind, my perspective would be, what would I expect to see today in a farm field? Maybe not what I would expect to see 10 years down the road.
Great. So the one thing that you mentioned previously, that we have these two types. We have our beneficial microbes, the microbial products, and then we have our biostimulants, right? And so I think we're going to dive a little bit more into modes of action in a second here. But I just wanted to get your perspective when we look at these two major, I guess, overarching categories of biologicals. What are some pros and cons of these two directions? Is there something that you see a greater future in, or is there something that you think is a better option for folks, if that makes sense?
No, it makes complete sense. And there's definitely a shift in where the market's going. As a researcher, I work pretty closely with industry, and I like working with industry because universities don't sell products. Industry sells products. Farmers buy those inputs from the industry. So I like working with the same folks the farmers are. And it helps us then hone in and understand how these products really work. And then we optimize that to really make an impact on the farm. The biostimulant side probably, what I would say, dominated this market more so than the beneficial microbes for a long time. If I mentioned fulvic and humic acids, alginate slash marine extracts, these amino acid products that are out there, or even things like sugars, most farmers I speak to say, yeah, in the last 20 to 30 years, those have been here or there, but not necessarily new. The last 5 years, it's these beneficial microbes that are dominating the market. I would say 1 out of 10 products fits that non-living side, either humic or an alginate that comes to me. The other 9 are some sort of living microbe. So that's where the future of the market I see right now is pushing. Pros and cons then. The nice thing about the fulvics, the alginates or the amino acids, they're already dead things. I mean, you can't kill it. It's in the jug. So it has the better shelf life and handling. Some of these living microbes have to be babied. And I'll give you a really good example. When we first started working with this, we had to buy an industrial fridge for our research program just to be able to handle the microbes so that we can ensure as best we can they're still viable from delivery to the field. And I always love going to the farms, and the analogy that I use describing the care to it. How many, when you go do that farm visit and in the shop with the farmer, right? Most of them have that beer fridge, and I love going to that beer fridge, right? And then having a good conversation. If you really want to get conversation going with the neighbor, say, hey, come on over, let's have a chat. It's raining. We got nothing better to do. Go grab a beer out of the fridge, and they open it up, and there's an inoculum on the bottom shelf. I mean, that'll get them talking about what are you doing over here that you have this inoculum in the beer fridge. Is the future of where we're going, you now have the beer fridge right next to the inoculant fridge. Or the companies figure out different microbes that are more hardy and don't need the refrigeration. Is it simply going to be that matter where we're going to be applying the microbes that don't require the refrigeration? So handling, back to your question, is probably the biggest pro slash con to what type of biostimulant biological should I use. Comes down to what infrastructure do I have to handle them and get them out to the field in an ethical manner. So that's the big one. Biostimulants can be broken down in the field. So once they're applied, if they're broken down by just natural processes or the microbes, then they're gone. A living microbe that colonizes the plant can continue to colonize, and so the benefit to those is you might get small doses of what they're producing, but you get them continually throughout the season. So one application gets you a lot of little doses, whereas on the other side, it's kind of a one application, and then you might need to apply again. Would be probably the other side to give favor to the microbes over the biostimulants.
So I want to jump back to this refrigeration and getting out there these beneficial microbes. And it's not just always the handling, but we have to be so very cautious of what we mix them with or what we spray in and around them too, right? So it's not just this initial thought of, I got it in the fridge. Now we're going to abuse it once we get it out there. Like, this is an investment for the season length or, a period of time that some of these other products can really damage these bacteria or these other types of microbes once you put them out there? Or is it kind of, now they're out in the soil, let them go and forget about them?
And I think that's a lot of the unknowns. What is the viability? I mean, we're going to do everything we can. I mean, you paid for that input. When it shows up, you're going to make sure that you do everything you can to keep it alive till application. I mean, it's just like seed. I mean, once you put the seed in the field, there's a lot that we're hoping happens for the right manner. Where things are also then questioning, did the delivery driver take care of it? Did the intern at the warehouse take care of it? How did it get from the production facility to the warehouse? There's a lot of unknowns on that pathway, especially when, like I said, you're paying for that input. How does it arrive? Very unique from something that is not alive. It's just a jug with product or like a pesticide. A lot of questions there on the viability.
I remember hearing from one of our nutrient management specialists in some of their testing of biologicals. What they found is that when they did their own trialing with certain biologicals, they didn't see any differences, right? They didn't see that the product did anything. And then when they got the product directly from the company, then it did something. So not only do we have to think about how we're storing it, the idea there is it came directly from the supplier who knew exactly how to store it to keep it viable. But then it changes hands, right? It goes to that dealer, and if the dealer's not taking care to make sure it's being handled right, and maybe it went through a few phases of storage, we just need to be ever so cautious about that when we're working with biologicals, and understand that risk as well.
And I would say that's probably when I'm going about this space, it's the education. I mean, that's really where my main priority is, not necessarily to try and say which products work and which products don't, but just provide the information so that you can make that decision for yourself. And Justin, back to your comment about mixing, because you alluded to it and then I kind of forgot to get back to it. Mix test is a great way to look at it. And when you're trying to pick between a product that may or may not be a fit for your farm, where I would say most people say, yep, here's a list of what we know it's compatible with. I want the list of what do you know it's not compatible with. I mean, have you done the testing to know these products 100% will kill the microbes, so don't mix it all? That also gives me an indication that that product is well studied, well understood, and has a better chance maybe than somebody that says, well, we don't know what it's not compatible with. We've tried a few things, don't be the guinea pig at the same time.
Yeah, and that was kind of what. So I remember this as there was a group 4 herbicide that was going over soybeans that was very popular for a while, and it's I don't know if we can say names or not, but when dicamba and extendamax and all of those things were coming out, the downside to that people were seeing was how that label was changing. And you were needing to get online and look at compatibility like 48 hours before application to make sure your adjuvants and your sprays and all of your things were listed. And as farmers, you're busy folks. And the last thing, we tell them at our pesticide meetings, read your label before you purchase, before you store, before you spray, as you spray and as you clean out. And I know that they all hear me when I say that, and I know that they're all doing it, or I would just go insane thinking about it. But I also recognize how challenging it can be for them to keep up with all of these changes to labels. And as we're advancing in technology and we're going through this process, labels change throughout the course of the year. That is not a static process, right? These are very dynamic, and we're talking about living things and things that change. And so it's not, I don't, again, back to being the wet blanket, the onus is not always all on the industry or the salesperson or something. As the sprayer, as the person putting it on the tank, you've got a little responsibility to make sure this is all going to go well too, right? I mean, we're all in this together wanting to get this product out there.
Exactly, and it is on everybody's, because it's easy over the winter to have that conversation
Right.
of, oh, I understand you need the refrigeration. I've got that in the shop. We'll get through and make it so that it's alive at point of application. And when it's go time, though, it's go time. And the best example is you got the inoculum, you mix up your first load, you set it on the tender trailer, and oh, we've got 2 row units down, and now you're on the ground for 2 hours trying to get the planter back up and running. And that poor inoculant jug has been sitting on the tender trailer right in the direct sunlight, and now they're cooking. And it's easy in the moment to forget about those little things. The fertilizer, you can leave that on there all day. It's not going to change. But this whole biological space, it's a totally new way to think about product management.
Yeah, that's a great point and a very real example of what it's like. And that's another reason why this is at this point maybe a value added perspective, right? You make sure that you master everything else first, right? Because this is going to be an added step and there's no way around that, right? Like it's not it's if you are missing some of these label instructions, if you're missing some of these, you're just not going to get much efficacy at all. So that's why you need to master some things before you jump into this space at this point. So maybe we can start diving into. I remember I heard you present at an Ohio Greens conference, and that's how I first kind of interacted with you. And you went through the biological modes of action that we kind of have today, and I thought you did a great job of kind of. There's so many products out there, but there are categories, right? And so I'm going to list these off, and maybe you can take it from there and tell us what are maybe some of the ones that we should talk about today, and maybe what are some of the modes of action that are most relevant in the future. So Here's my list. Here's your list that I took note of, and I'm going to repeat to you.
And
Yeah,
whatever
just
you tell us is most relevant for the future, we'll just schedule another podcast and whenever you tell us, and then we'll just revisit those. So feel free to just say whatever you think's necessary.
that's right. We're going to quiz you on them. You know, we're going to take note, give us a timeline, and then we're going to see if you told the future or not. So we have nitrogen fixing biologicals, okay? Phosphorus solubilizing microbes, and those are also phosphatase, which is an enzyme, right? We have mycorrhizae amendments. We have residue degradation amendments, enzymes, humic and fulvic acids, marine extracts, and sugars. So those are all the ones I noted. Do you have some ones that you want to pick there to talk about?
Yeah, I'll give you the let's see if we can do this. The 1.5 minute like snapshot of the presentation that you and I caught up at. I mean, if I go through those categories and give you my key takeaway for each category in brief, nitrogen fixing bacteria, really cool. Pulling nitrogen out of the air to give it to the crop. Why this is so important. In our systems, where do plants get nitrogen from? It either mineralizes from the soil or we supply it with fertilizer. We do everything we can, but fertilizer is sometimes lost to leaching and volatilization, and mineralization is good years, bad years. What's the weather? So we have two sources. I mean, how long have we been growing crops? We have two sources of nitrogen. What if we can make a third source an option? That's where it gets really exciting. Today's market, I'm not as much, let's reduce our nitrogen fertilizer and replace that with the microbe. Let's keep maintaining what we've been doing, or remove those 20 pounds of insurance nitrogen you've been throwing out there. And the nitrogen fixing microbe is that third source of nitrogen where the soil or the fertilizer lets you down. That's the big takeaway on end fixers, thinking of as a third source to help balance nitrogen across the field rather than trying to replace it. The phosphorus solubilizing microbes, the initial thoughts behind those are they release phosphorus from your soil, and therefore you could use less fertilizer. What I think is really happening is what if you prevent the fertilizer from getting tied to the soil in the first place? And the way those phosphorus microbes work is they chelate cations, and that's the idea of creating a barrier. So rather than try and use a phosphorus solubilizer to replace your fertilizer, where we see our best success, put them right with the fertilizer, full rates, and it gets them more efficiency, more bushels per the same unit of fertilizer you had been, because it's protecting it. So on phosphorus solubilizers, don't replace, but just it's an additive. Mycorrhizae, we touched on that. You know, heavy tillage systems, probably not your best bet. We talked about the residue degradation. Just some key snapshots. These are living things, so don't spray them on a really bright sunny day that's going to be 90 degrees. Give them a chance to get into the residues. We either spray in the evenings or a cloudy, even a drizzly day, because that drizzle can get them into the residues. A little different perspective than like a herbicides where you don't, the rain fast. We don't necessarily think about rain fast as much on the residue degraders. And then the humics, the marine extracts, the sugars, and the enzymes, thinking, time it right because it's kind of a one-time dose. And once they're used up, you're going to probably have to hit them again. So thinking about what's the goal. And then back to just let's wrap it all up based on those. What is the goal? Why do you want to try a biological? Find the right fit for that need rather than let somebody knock on your door and say, here's a free sample, put it on 5 acres. Because does that 5 acres need what our product does? Could be not. So
Yeah, that's a great point. Find the products that you need and try those first. Don't just try it because someone says it's going to be the magic bullet. I think we need to look at what are the problems we have in our fields and solve those. There's a million things we could solve, and we don't want to create more problems. Now I'm going to pitch that second part of the question back at you, and what do you find, which products do you find are most relevant today, and which products do you find most exciting in the future?
So I'm probably going to go backwards order from what you listed because the second four are what I would say the most common biostimulant slash substance, a non-living. And the humic and fulvic acids and the marine slash alginate extracts have been around. Those are not new necessarily. So I think there's some familiarity there, but there's so many different options and choices within there. Our humic acid is a leonardite based versus those that come from a compost based. So you could say it's the mineral versus the more organic sourced materials for the actives. The alginates is a similar thing. You hear, it's got to be this algae from the west coast or east coast of Canada versus the one that comes off the east coast of France. And the different algae that grow in different places have different bioactives to them. But these have been around, and so they're more common. When I think about so back to your timeline example, and to protect myself for the future when you use this recording against me, I am an agronomist, so I'll just precede this with all "it depends," the two words that we use the most. So that the timeline may or may not change, but those I would say are the more current / historical. And where we are going with this is definitely those first four you listed, the living microbes. That is where the future of the market is headed. Couple reasons. At their base, the active ingredients of the alginates, the humic acids, or the sugars are relatively consistent. I know that you can get different blends from those, but at the end of the day, the chemistry structures to them are pretty consistent. When you think about a living microorganism, there are so many species that we could be pulling from. And just thinking about dogs as an example, right? We know, you could say N fixers are dogs, but there's a lot of different breeds of dogs. And then within dogs, you have different colors. So I have Australian Shepherds, but they come in 4 colors. So you got the black chives, red chives, like blue merles, red merles. So within the microbe species area, it gets a little complicated because you can classify it as a nitrogen fixer, but then within that, there's different microbes that do that in different ways. And then even within those, they have different species. Technology, though, has come a long way, and it's really exciting where it's going. Why is the living the future? There are better tools to just understand who is in our soils, who's doing the work that we know about cycling nutrients. Then we isolate them, we get better at formulating them, we get better at keeping them alive, and now we've got stronger products that might have better consistency to them. Why I think that's where the future of this market's going. Today, what we see in our research, the phosphorus solubilization, the residue degradation, and the humic and fulvics are probably the most consistent in terms of a yield response and minor yield response. I mean, we're talking 3 to 4% yield increases is a good day, especially in our corn and soybean markets of today. The nitrogen fixing, there's some products out there today that have some efficacy, but I think if we can really hone in on those, that will change a lot of the future in the 10 to 15 to 20 year lineup.
Yeah, so let's focus for a second on those nitrogen fixing and phosphorus solubilizing microbes. Um, so one of the questions that I always kind of think about when I'm thinking about these products is how do we know if they're effective, right? Like what are the steps we need to take when we're implementing these to even know if they're having an impact? And also, how do we even know that they're a living microbe that's supposedly doing something, right? And when we drop them onto the field, they're dropped into an ecosystem, right? Of a bunch of different microbes, predators, prey, whatever, a food web, right? Of microbes. So how do we know that they can survive? And how do we know if they will survive in any context we give them? Do you have anything to kind of share with what we know about that ecosystem, right?
Well, first thing I'll go back to Justin's comment, check strips. I mean, every practice that you do, even if it's something you've been doing for 10 years and you say, well, I do every acre because I know it works. Okay, but put a check strip in. Maybe it's not working like it used to. So, I mean, that's the first look at, is there efficacy on the yield side with the check strip using the map? One of the things I hear about N fixers, and we believe this too when we started the research, if they really are fixing nitrogen, and especially for corn crop, that's the background I would have, they should show at 0 nitrogen rates because any nitrogen should go a long way. So if you want to see, because microbes we can't really see with our eyes, so we have to trust that they're there. But if you really want to see something, everyone thinks they should work at 0 nitrogen. And we thought the same thing. We did about 4 years of putting these 0N checks, and we weren't getting any responses, any results. And we're like, this is where they're supposed to work. But then you think about it, where these microbes work is on or inside the plants. And therefore, you need a good, healthy plant to have good, healthy microbes. And we learned then that you need at least some nitrogen to get the plant started so that it can produce the exudates to then feed the microbes to pull the nitrogen in. So a lot of folks start 0N check with and without the microbes, should at least tell me it's working. But maybe we need to do like a 25% nitrogen rate with and without to better see it with our eyes. That's about the best visual we can get today because these are commercial products and there's patents involved. So you can't soil your sample and have a third party sequence it to say, can you find the inoculant? So that is one limitation to the space. It's hard to 100% confirm that that inoculant has established because it's not like our legumes that will produce the nodules, right? That we can see the nodule. With these N fixers, largely in what I would say the grass crop space, that's what's changing the game, is for corn and wheat and sorghum. You don't see that nodules. So they're either along the root sheath or inside the cells, harder to see. So it is complicated. And how do you know? But that would be my first suggestion is a reduced nitrogen, a severely reduced nitrogen rate with the product, just to make sure that you give the plant the opportunity to then work with it. And then, yeah, check strips at the end of the day. I think we'll say it for a third time to make sure that hits home. Check strips go a long way.
And I think many of us, I don't know, sometimes I'm not as old as I think I am, but I say things like chlorophyll meter and SPAD testing, right? Check strips were a very viable part of what we were doing with that, right? Before we came through all of the tests and we had years and years worth of validation of this is what you needed and this is what you got from the numbers. Check strips were a very common practice to low in, no in, and using that to kind of back check all of your chlorophyll meter testing or SPAD meters. And so, I think most of the farmers should be very familiar with what these check strips look like. They should have gone through the process at some point in time. And if you're not, shamelessly, I can plug extension, right? Every state has extension. And so if you're sitting around there listening to this thinking, I've never put in a check strip before, I'm not sure how I would set this up or where I would set it up or how I would even make sense of this data, I would encourage you to call your local extension agent or educator or whatever they call themselves, because I can almost guarantee you they would be happy to come out and help you look at biologicals and get some data on this and connect with you in a very real world situation and something that could be useful to a lot of other producers. So
Yeah,
go ahead, please.
yeah, I was say I agree with that, and then also make sure the check strip isn't on the headland because then it's guaranteed to work.
That's right. Yeah. Yeah. So, right, that's where we have to kind of think about some of these things. And I'll say that citizen scientist again, right? We're all kind of in this and we're trying to figure out a way to make some of this stuff work and figure out how we can use it to our advantage. The one kind of subcategory I think that's most interesting to me is this residue degradation. And you said that's one that you see a lot of consistency in its usage and maybe not its usage, but its functionality. Can you walk us through that? Because I do have some growers that use that, and I've got some question marks in my head. Where do you see that in your research? And talk to us a little bit about that one.
Yeah, this is probably the category that's also expanded the most rapidly in the last few years. So the nitrogen fixing definitely, I think, reopened the door. Like I said, soybean and clover and other types of legume inoculants have been out there. But when we started talking about N fixation for grass crops, suddenly the biologicals really took off. This would be about 2017, 2018. The new topic of interest that's taking it further is this residue degradation spot. And I'm in East Central Illinois, so it's pretty well a corn soy rotation with a fallow over the winter and 2, if not 3 tillage passes, fall and then a 1 or 2 pass in the spring. So a lot of folks come to me and say, that's my system. So fallow, full tillage. Why should I care about the residue side? And then I flip it a little bit and say, have your yields gone up in the last 10 years? They say, well, yeah. So you have more residue out there because for every unit of grain you produce, you get an equal increase in the amount of residue that you're putting out there. And I think that really then makes this whole residue space now for every acre, because cover crops or no-till is an obvious scenario of I have more residue on my farm. But then you throw are your yields going up? And as we go up with yields, we get more residue going out the other end of the combine. So that's where it gets exciting talking about it because there is so much versatility for all the acres. We've been looking at these as fall applied onto no-till corn stalks. We've been doing them with the spring pass terminating cover crops, so try and get them to break down a little faster. And then we've started in our area, double crop is making a comeback, and that wheat straw might have some nutritional value, but not very quickly releasing for that next soybean crop when we're trying to do it in one season. All three of those rotations that we've been looking at these practices, we're seeing modest yield increases. Um, Definitely, enough to pay back for product. And then this also brings back though, what should the expectation be and how are you measuring yield? In the small plot, we can get pretty precise. We're talking 3 to 5 bushel differences on corn. And our corn yields in this area are 250 bushels or so. So it's a very small percentage. The 5 bushels usually pays for the product. And because it's usually going out with the sprayer pass that you had to do the herbicide, it's considered a free ride. But also just putting in perspective of what's your expectation. And the other thing on a yield monitor, you may or may not see a 3 to 5 bushel difference using a yield monitor versus calibrated weigh wagons, kind of as you mentioned earlier as well. So that's where we are seeing some success. Really excited about it. We do see some activity on the bulk residue. I mean, you can weigh corn stalks, spray them, and weigh them again and see them degrade. The organic matter cycling though in our soils is so fascinating, and I think we know a lot, but we really don't know a lot. There's different pools and levels. I mean, you have the residues on the surface that you see, corn stalks or that cover crop biomass, but then as it breaks down, it comes into smaller chunks, and then those small chunks become smaller chunks. And what I don't know is how much of these residue degraders are working on the big piece versus the little piece versus the smallest piece. Probably all of the above, and why I think we're seeing some of that consistency, because there are certain levels of organic matter in every field. Even if you have a 1% versus a 4%, those layers exist. And that's partly I think giving these residue degraders the advantage on consistency versus some of the other products that might be a little more picky and environmental specific for getting a response that we can see.
So this might be one of those things we file in the dumb question category from Justin. But so in my mind, when I think of heavy residues on a field, right, in Pennsylvania, we're a lot of no-till. And so, we've really gone back to a lot of corn bean, maybe a small grain type system, but we're seeing a lot of our forage perennial sod type parts go out of our systems. And so it's becoming a lot of rotational row cropping. When I think about buildup of residue, my mind first goes to high levels of carbon, right? We're not to that 30-to-1 C to N type ratio situation. And so then this question comes in, what if I did a fall burn down with like some UAN or something in there and applied a little bit more liquid nitrogen on that cover crop to that? Will that not help break that down in a more cost-effective way that I'm also maybe working with my cover crop? Or is that just not the way these things work and I'm totally off base?
We've been doing research that looks at that exactly. We haven't done strict UAN yet because we're actually doing nitrogen and sulfur containing practices like ATS or AMS. Certainly, that helps break down the residues. We see actually that almost gives us a better response than the biological on its own. And what's really exciting about the biologicals and why we are optimistic about where it could go is this systems approach, where the nitrogen and sulfur helps the natural microbes get going, but then we add another microbe on top of that right onto the residues, and it just keeps it going at a higher level. The way I kind of talk about the residue management, because we also look at sizing of corn stalks on the combine with like a stalk roller. And I know there's different tools and technologies out there for that, some on the combine, some afterwards. When you eat a steak, most of us chop it up into small pieces, right? And then knife and fork it and then chew on it. Makes it more digestible. Sizing residue helps the native microbes just get better access to it, better surface area. But back to that C to N ratio, it's usually really high. And a high C to N ratio is not easy to break down. It's tough. Can we make that more palatable? And the way I phrase it, it's like putting a little salt and pepper on the steak. Little nitrogen and or sulfur makes the residues more palatable for the native microbes to break down faster. And then the icing on the cake is let's put on another microbe direct on top. That's why the residue space goes through. I get this challenge though. Should we be recommending fall applied nitrogen? And I say, yeah, that's a good point. But keeping in mind modest amounts. The goal with the fall nitrogen application as a residue management strategy is we want it to immobilize. We're doing in our research about 40 units of nitrogen on the fall in no-till, but the intent is that those 40 units are immobilized as the residue breaks down, and then hopefully remineralizes in the next spring. But it will change the discussion about fall N. Is it fall N as a fertilizer application or fall N as a residue management strategy? Two different perspectives. The other thing we don't talk about much is the C to S ratio. We talk about C to N ratios, that ballpark 30 is maybe the balance that we want. If you're above that, you're going to induce immobilization. And if you're below that, you'll mineralize. Sulfur is important for amino acids and proteins as well. And the C to S ratios of residues can be somewhere around like 350 to 1. That's why we're looking at ATS or AMS, because we think that's giving a little bit of an edge. The nitrogen might be getting us a little bit of the way, and we think the N plus the S is the next step. Haven't designed in our studies yet a nitrogen only, a sulfur only, and then a combination source. That's probably where we need to go. But putting us all together, it's just helping the system break the residues down faster, because as we continue to push yields up and up and up, it's the same fields we've been farming for the last 100 years. And are those fields accustomed to that much residue, or do we have to start helping them manage something that they maybe weren't used to 50, 30, 40 years ago?
But I think this goes full circle to where we started, right? Is you're talking good agronomics, then we talk about the microbe or something to help us, right? And what we're talking about now is the basic kind of fundamentals of degradation and composting. Is what do we do to make some of this go away? Well, we look at a little bit of the N, we look at a little bit of sulfur, right? Those are the things that are going to help. We want to enhance that a little bit further. We have all the other fundamentals in place. Let's talk about a microbe on top of that to kind of work top to bottom and sandwich them from soil kind of down. And so, that's the way this works. We can't look at this as we're not going to do anything else except go out here and take a single pass and spray the stuff on here and expect it to be gone by springtime.
Exactly. And the other thing I hear is, oh, all right, if I accelerated that residue decomposition this year and I got more of those nutrients to release for this year's crop, wouldn't they have released 2 years from now and fed my future crops? And I go, yep. So the question is, by accelerating the residue decomposition, are we stealing from the future cropping systems? But back to, if we're then using that to get a higher yield, and then we keep pushing the efficiency of the system, that's the pitch there is it's to get the whole system going, but ultimately higher yields will then return more nutrients back as we keep going down the road. So, yep, it all works itself together in the end.
Right, and this also might be one of those situations, right, where we're looking at our cropping system and maybe particular fields, right? I have fields that I go into based on the cropping rotations that you still see a fair bit of bare soil, and they do a no-till system, but if it's a dairy system, they're pulling off a lot of residue, right? And so maybe you're right. I mean, you could argue it both ways, right? Do you want all of that to break down and feed that crop, or is it just fine the way it is? Then I have other fields that they're doing a no-till rotation that's pretty intensive cover crop, followed by soybean, corn, even sunflower, very dynamic. And you can sometimes see residue that's there from 2 years. You see multiple crops worth of residue. And those might be the cases where, okay, now it's probably about time we think about how do we accelerate some of this residue degradation. So I think this also, like every single one of these practices we're talking about, this is something that you need to try on your own. And maybe this is something you can also do some trialing with on your own farm, and see how it works for you. Um, so I think we talked about initially some of those biostimulants. You mentioned sugars and the humic and fulvic acids. One thing that just keeps coming around is to me is molasses. A lot of my farmers are using molasses and other sugars, and I just wanted to get your thoughts on, is that molasses effective? Is it doing anything? That the idea being that it is allowing more microbial life to persist, and allowing for more nitrogen availability through microbial metabolism. And I hear all kinds of things about it. So why don't you talk about sugars and tell us about it yourself?
Yeah, tell you just how sweet is it? Um,
Yeah, right.
so sugar's again one of those that I wouldn't say people would say are new, and a lot of when I hear about sugars, I mean, those that are using them swear by it, and they say, I will never not put sugar out. And then there's the other side that folks say, no, I think sugars is just kind of a marketing thing that may not work. Where I have seen traditional use of sugars be is with foliar applications. And on their own, we've been hit or miss. I mean, we had one 11 bushel, one site year response to a foliar sugar at like V5 corn. I'm like, holy smokes, for 4 pounds of sugar at V5, I get 11 bushels. That would be awesome. Have not been able to replicate that response since. And sometimes we've seen it even go backwards 3 or 4 or 5 bushels. We call this the Goldilocks principle, right? So is the porridge too cold or too hot? Nope, we need that sugar rate just right. And this year it's 4 pounds at V5 because that's how the crop was feeling today. But next year it's 6 pounds at V4 because the crop is feeling a little different. It's really hard to hit that sweet spot on foliar. And this would be the sugars and then the alginates, anything that goes on at kind of a foliar is that whole curve of what's the optimum rate for the conditions we're under. Hard to hit that. Where we're seeing some interesting now, more consistent though on the sugar side is the in-furrow market and putting them in the soil application versus the foliar. Where this gets interesting is it's like a fake root exudate, and why that sort of makes sense. The microbes in the plants in our soils, they interact all the time naturally. We learn this in our basic agronomy soils courses. Microbes are out there, plants interact with microbes. What's the problem at planting with a seed that goes in the ground and the microbes in the soil? They're waiting 2, 3, 4 weeks before the plant is big enough to start sending the signals out and start that communication process. If you put a sugar in furrow and it's close enough to root exit profiles that it basically like tricks the microbes into thinking, oh, the plant is here and it's active before it really is. And that's where we start to see better responses to the soil supplied and furrow sugars than maybe the foliar side. Those that are foliar sometimes claim it helps with like micronutrient movement into the leaves, sort of as a surfactant play. I wish I could go more on that. No personal experience looking at with or without different additives. We've just tried them foliar on their own. But the soil side is interesting. We're using in our work a corn syrup base, which here's your fun terminology of the day. What do you call it when you use a corn syrup based application to grow more corn? We call that cornibalism, feeding corn to make corn. But the high fructose corn syrup has a glucose fructose ratio similar to the glucose fructose ratio of root exudates. So that's really to back to your question. What we think is happening is it's like an artificial root exudate telling the microbes to get up, get to work a little bit sooner than they would naturally on their own. Less consistent on the foliar side from what we've seen.
Well, that's interesting because the majority of folks that are applying it are using it on the foliar side. So that's an interesting factoid there. I like your cornibalism term, but I think that we have a lot to learn when we're talking about the root exudates that are stimulating microbes, and this is something that's fascinating. We could probably do a whole podcast on just that. What's going on and how our root systems are selecting for the microbes that are beneficial.
So I'm
Um,
already taking notes for our next podcast so that we
yeah,
can bring him back again. One of our discussions is going to be foliar versus furrow, right? And maybe breaking down a couple of these and the topics because this is such a huge, heavy conversation. I'm sure you see a lot of different responses, just like the sugar and dextrose and stuff of what works better where.
yeah, that is definitely would definitely be a good topic for the future, and it sounds like there's a lot of places that this as we're talking about all of these different you know compounds and microbes. There's a lot of space in this to learn, and we are really just in the early days of learning about how to best implement these, even with some of these things that have been around for a while. So kind of one question to maybe wrap some of these out, because I don't think we have time to go through every mode of action here, but I think we've gotten some really important ones covered. Are there, so one of the things that I often think about when I'm thinking about these biologicals is the functions of some of these biologicals are probably already in your field based on the native microbes, the native ecology of that system anyway. So is it possible to and maybe this is hard to answer on a broad spectrum, but is it possible that you can fulfill some of these functions without actually using biological products? Are there ways that we're learning that you can use agronomic practices to do some of these functions otherwise?
That's a great question, and in short, yes. And I think that's, I mean, maybe this is the underlying theme of the whole discussion is the systems approach. Um, I'll use AMF as an example because one we haven't touched about on them much yet. AMF are fungal, and fungi are much bigger physically from a biomass perspective than microbe or than bacteria. But the way that AMF really work well is they develop this hyphal network and they grow long hyphae that explore deep into the soil or can cross row to row. And they develop over time, and they might develop well in the first season, but give them a little bit of time or re-inoculate the next year and then let that population grow. Therefore, reduced tillage systems are probably more conducive to the use of AMF. But if you're in the organic system, going back to when we kind of, where we met and talked about pros and cons to different categories, AMF inoculum is probably not something I would recommend for an organic system because you're under heavy cultivation, in-row cultivation for weed control. And every time you disturb that soil, you probably disturb the hyphal network of the AMF. And so you paid for the inoculant, you put it out there, it started, and then something else you do on the farm prevents it from going further. So that's another kind of conversation, is that the product doesn't work or that the conditions it was placed into are not suitable for that product to do its job. So no-till, really beneficial more for those hyphae AMF type colonies would be one example of a practice that interacts with the natives that you may or may not have. Gosh, that's a good question too. What other practices to think about?
Well, I'm
Uh,
glad you mentioned AMF here, because this is one of the things that kind of I've spent a lot of time doing in my research days. I did a lot of work with AMF, and what we noticed with some of these products by and far in Pennsylvania, we seem to have, because of a lot of our systems being no-till and a lot of wheat and corn rotations, at least in my area of the state, I was finding there when we were doing looking at these under the scope root samples, we couldn't really tell a difference between those that were inoculated with AMF and those that weren't. And it was because we seemed to have adequate levels of AMF already there. So I'm glad you mentioned that one, because that was kind of one that I was kind of thinking about. But you can go on there. I think you were extending this to other examples, but that's a really interesting one. That at least I see in Pennsylvania soils, we already do have a high level of native AMF, and sometimes I'm not sure that those products are even that effective.
yeah, no, and that makes complete sense. And it kind of goes back to what tool or do you need to put onto the farm and what is not conducive to the farm. If you already have the AMF, you already have that tool there. What is maybe lacking? The other thing that I often hear about fertilizers in microbial communities in our soils is they claim fertilizers are not good for microbial communities and the soil health of those microbial communities. And our data just does not show that here in the Illinois soils we're working on. When we have fertility, we have a good, healthy system. There's no doubt you have zero fertilizer checks out there in the field, and you can tell that corn or soybean crop is huge growth response. What does a good, happy, healthy plant do? Produces a lot of good residue or root exudate production that then feeds the microbes. So good, adequate nutrient management is not just good for your crop, it's good for the microbes in the soils. And so often I hear fertilizer bad for microbes in the soil, and that's just not what we see. Now, I understand, a fall anhydrous nitrogen application can create that hot zone right around where you banded it, or maybe a really salty starter right in the vicinity. but their soils are vast and they're deep, and what little effect you may have in that isolated zone eventually dilutes out. The communities come back, and then that nutrition is in the system, helping with the crop development, the microbial development. I mean, we've seen where fertilizer additives increase the enzyme activities of the soil test because we gave the microbes nitrogen, phosphorus, so now they're looking for sulfur to balance. So, um, back to just good nutrient management, not just good for your crops, it's good for your microbes as well. Uh, Similarly, pH, back to what practices can help your native microbes. Plants like a certain pH just like microbes do. I mean, we often hear that AMF do well at low pH or they thrive there. That's actually not really the case. Bacteria just do really bad at low pH, and AMF and fungi just tend to tolerate it better. So if you have low pH, you might think, my AMF are more, or my fungi are more abundant, and like, doesn't mean they're happy. It just means they're tolerating it much better than the bacteria that were weaker just couldn't make it. But they would rather be closer to neutral than acidic. So pH nutrient management. A lot of times, I think what would make a happy crop probably going to make for a happy microbe.
Awesome. Well, I think that's a great place to wrap things out. Take care of your crops, take care of your microbes. It sounds like a lot of these agronomic practices that you can do can aid in the benefit of those microbes as well. And that's where we start, right? We kind of started by talking about we start with our agronomic principles, and then these are value added products. So Dr. Sible, is there anywhere you want people to find you, your research, anywhere you want to direct people for that?
Yeah, so we do have a lab website that we keep up to date in our spare time, which there never is any. You know how it goes. But that's cropphysiology.cropsci.illinois.edu. We can give you a link for that. I am on X, formerly Twitter, just at Connor Sible. And so I try my best to post on there updates, what we're seeing. And those would probably be the best two places to find information about what we're doing. If you want to direct contact, my email, of course, is freely available at sible2@illinois.edu.
Awesome. And we'll make sure to put all of that information in the show notes. So, Dr. Sible, thank you again for coming on. This has been a pretty illuminating conversation on biologicals. It's a little bit like drinking from the fire hose, but any one of these topics could be a whole episode. So, I think you did a great job of really breaking this down. And I think there's a lot to learn in this topic. So, thank you very much. And for our guests, thank you guys for tuning in to another episode, and we'll catch you on the next episode of the Agronomy Highlights podcast.